In this video, we're going to look at a constrained resources example. And so at the top, there's an example where you can walk through calculating the contribution margin per product line and then breaking that down to determine the contribution margin per the constraint. And then from there, deciding how to prioritize the best product mix. We're going to do that down in the example. So feel free to look at the example that's already solved for you, and then I'm going to walk through the practice problem with you now. Southern Colorado Woodworks makes two products, chairs and tables. The sanding machine is the bottleneck. We only have 9,000 minutes available per month to use the sanding machine. We see that we have a selling price for each product, a variable cost for each product, so we need to calculate the contribution margin, and that's going to be equals our selling price minus our variable cost, and that gives us a contribution margin for the chairs of $33 and for the tables of $65. We also see here that the sanding time for the chairs requires 3 minutes, and for the tables requires 5 minutes. And that as far as monthly demand goes, we have demand of 2,000 chairs or 1,500 tables. And I should say and, not or. So what we need to do to solve this is first calculate the contribution margin per minute for each product. So we're going to break it down and calculate the contribution margin per the constraint. And then we're going to decide which products we need to prioritize and produce first, and then calculate the optimal production quantities. So we will do that down below. We will start by taking our contribution margin per unit. And so I'm going to just put chairs, tables. Okay, so we already calculated the contribution margin per unit, so we can just cell reference up to where we did that. $33 for chairs and $65 for tables. Then what we need to now do is calculate it per constraint. So if we look at quantity of constraint, we know that it requires 3 minutes of sanding for chairs and 5 for the tables. So for us to determine the contribution margin per constraint, we will divide the contribution margin divided by the number of minutes per constraint. And so we have a contribution margin of $11 for chairs and $13 for tables. If you're interested in converting that to hourly, you can by multiplying the contribution margin per minute times 60. And so we can convert that to the hourly contribution margin. You don't have to do that, but sometimes people just like to see that. So from right here, we can see that it makes the most sense for us to prioritize tables first and create or produce as many tables as we possibly can. And then however much time we have left, we'll use on creating chairs. So let's do, down here, we'll say demand for the tables was 1,500 units. And we know that it's going to, let's just do, it's going to take us 5 minutes. So 1,500 times the 5 minutes per table. So it's going to require 7,500 minutes of time to produce all 1,500 tables. That's going to lead us to figuring out how much time is left for chairs. And so if we have a total of 9,000 minutes, 9,000 minus the 7,500 we've already used means that there's 1,500 minutes left that we could use for chairs. And we need to now figure out the quantity of chairs that we can produce within that time frame. And so if we take the 1,500 and divide it by the 3 minutes per chair, we see that we can produce 500 chairs. So our product mix is going to be to produce 1,500 tables and 500 chairs. The last step I told you was to calculate the total contribution margin for this combination of things. And so we can do that down here. We will say units, chairs, tables, total. And so the units is going to be 500 chairs, 1,500 tables. Obviously, that's a total of 2,000 units. And then the contribution margin per unit is $33 for the chairs, $65 for the table. And so now we want to calculate total contribution margin, and we will do that by multiplying the number of chairs times the contribution margin per chair, and same thing for tables. And then we can sum that, and we see that this combination of products creates a total contribution margin for our company of $114,000.